Hello, my dear students. Hello, my dear students. Welcome to IMS GATE Academy. I hope you are doing great. My dear students, have been explaining in every video that very good afternoon, Srijana. My dear students, whenever you want to be success in GATE, my dear students, you should be consistent and you should follow a systematic concrete plan. As part of the foundation course, we are here to help you the basic conceptual things, and also we want to solve some previous year GATE questions which will revamp your basic knowledge on the subject. So today's topic is nothing but today's topic we are going to discuss is the stress distribution, my dear students. Today's topic I would like to discuss here is the stress distribution. Okay. 1 second, students. So, when I talk about stress distribution, students, why do you want to study about stress distribution? My dear students, when you talk about the loading, we have different types of loads, right? Actually, due to the load, there can be some stress induced. Now, my dear students, I will explain you a small example. Suppose if I consider a soil surface. Okay, very good evening, Thirumal Reddy. If I consider a soil surface, on soil surface, if suppose a building is constructed with 3 floors. Now, actually, the soil will be subjected to a load of the entire structure, or we call the soil is subjected to the weight of superstructure. Okay. Now, in the soil, how the stresses are induced, or what is the bearing capacity of the soil, which areas are critical, or where do you find maximum stress, how the stress has been distributed. You have to identify the pockets where the stress is maximum, because at that point, it is a critical point, or you can say that point is more prone to failure. So to identify the areas where there can be more chances of failure, we are studying about a topic called stress distribution. My dear students, I've been explaining in the previous topics also, a stress is nothing but a force per unit area according to the formula. But my dear students, I would like to tell you, stress is a tensor quantity. It is not a vector or a scalar for your information, which comes in strength of materials. So, my dear students, as part of stress distribution, we would like to study about a theory called bosniks theory. Okay, we are trying to study about a theory called bosniks theory. So, bosniks has done some experiments on the soil to understand the stress distribution, my dear students. So, what are the assumptions of bosniks theory? My dear students, why do we assume some assumptions is to make the complex problem into a easier problem. So, if there are n unknowns, you might find difficult to find out the unknowns. So, in that case, to limit some unknowns, you will assume some assumptions. So, the first assumption in bosniks theory is, why I am telling assumptions also, my dear students? The concept is simple. There can be a multiple select question in GATE exam. By giving the assumptions of bosniks theory, you have to identify the correct statement. So, this is very important. So, the first assumptions we have observed is, soil is homogeneous. Soil is homogeneous, isotropic, and semi-infinite. What, my dear students? Soil is homogeneous, isotropic, and semi-infinite. Immediately, Srujana will ask me, sir, what is actually do you mean by homogeneous? A material is said to be homogeneous if it has identical properties in the identical direction, my dear students. When you talk about isotropic, A material is said to be isotropic if it has same properties in different direction. And what do you mean by semi-infinite, my dear students? If it extends infinity in all possible directions, then we call the soil as semi-infinite. So if I consider it in a straight line like this, at every point the properties are same, then we can assume it as homogeneous. If the properties are same in different directions, my dear students, then we assume that it is a isotropic. And if it extends infinite in all the directions, then it is known as semi-infinite, my dear students. Now, my dear students, if I consider a soil strata, if I consider this as a soil strata with a depth Z, okay, and there is a point load, and one of the important assumption here in Bosniks theory is he has assumed the load to be point load. Now immediately you will ask me the question, sir, if it is a UDL loading, how do you convert that into point load? Just multiply over the length. If it is stress, multiply with the area to convert it to a point load. Because the problem they have given here is, they have assumed that the load is a point load. And if you consider the stress at a radial distance r, we have to calculate what is the vertical stress. So the agenda of Bosniks theory is simple, my dear students. We have to identify the vertical stress at a radial distance r when a point load is acting on the soil with a depth of Z. So my dear students, the Bosniks theory is given by the formula sigma Z is equal to Q by Z square multiplied up by 3 by 2 pi into 1 upon 1 plus R by Z whole square whole power 5 by 2. Now my dear students, if you find this formula is difficult, you take a screenshot of this formula, and I might be funny, make this as a screensaver or a screenshot and put this as a status in WhatsApp, because people are more habituated to see the mobile. So whenever you find this much difficult problems, this is some of the workaround. So here my dear students, the vertical stress at a depth Z is given by the formula Q by Z square into 3 upon 2 pi into 1 upon 1 plus R by Z whole square whole power 5 by 2. Again I am writing here, it is whole power 5 by 2. Agree my dear students? So this is, I hope you are clear with this formula. Srujna, is it okay? So if you can remember this formula, we will solve some problems, beautiful problems, my dear student. So what is that beautiful problem? We will discuss. See. Now see students, we have a beautiful problem here. Very good, Srujna. I really appreciate you, Srujna, for your commitment towards the GATE classes. I have seen right from the first day you are attending the classes. That is a very good sign for your success. Now see students, a rectangular area 2 into 4 meter carries a load of 8 ton per meter square on the ground surface. Find the vertical pressure at 5 meter below the center and at the corner of the loaded area using the Bosniks equation. So my dear students, here what they have given, a rectangular area was given. Okay, it is 2 meter and this is 4 meter. This is 2 meter and this is 4 meter. So here he is trying to ask the vertical stress at the center, and also he is trying to ask the vertical stress at the corners. So I told you, my dear students, one of the important point is Bosniks theory has assumed that the load is a point load. Here it carries a UDL of how much? UDL of 8 ton per meter square, my dear students. It carries a UDL of 8 ton per meter square. Now what will be the load, my dear students? So here when I talk about the load, what is the load here? Load, point load, you can write load Q is equal to 8 ton per meter square, and it is acting over the entire area. The area of the rectangle is 2 into 4 meter. So the total load here is how much, my dear students? It is equal to 64 tons. How much, my dear students? It is equal to 64 tons. Okay, what is the depth of the soil strata we have? We have the depth of the soil strata is 5 meter. So let us see what is the radial distance at center. What is the radial distance at center? At center, now see students, very important. At center, radial distance R. At center, radial distance R is equal to 0. The radial distance is R is equal to 0 at the center. Very good, my dear student. Now if I consider sigma z is equal to the vertical stress at a depth is given by the formula Q by z square multiplied by 3 by 2 pi into 1 upon 1 plus R by z whole square whole power 5 by 2. Am I correct, my dear students? So here what is the load we have taken? We have calculated the load as how much, Srujana? It is 64 tons upon what is z square? It is 5 square into 3 upon 2 pi. And this value as R is equal to 0, this will be equal to 1. Yes or no? As R value is equal to 0, this value will be equal to 1. Now can you tell me what is the value of this? Can you tell me what is this value? 64 upon 25 square into 3 upon 2 pi. What will value? Can anyone tell me, my dear students? So if you solve this, you will get a value of 1.22 ton per meter square. So this is the value of the vertical stress. Very good, Srujana, very good. This is the value of the vertical stress at the center. Srujana, please keep a note at the center. When we take at the center, the radial distance is 0. But when you talk about the radial distance at the corner, so if we have to divide the rectangular into parts. So this will be equal to 1 meter and this portion will be equal to 2 meter. This portion will be equal to 2 meter. So if you observe here, this portion whatever we are having here, this will be equal to 1 meter, and whatever the portion we are having here, this will be equal to 2 meter. So here whatever I write R is equal to what, sir? Root over x square plus y square, that is equal to root over 1 square plus 2 square. So that value will be equal to root 5. What will be the value of R? R will be equal to root 5, my dear students. So where is the R? R value is root 5 at where? It is the value at the corners. Clear, Srujana? Now see, the vertical stress at the corners, at any one of the corner we are taking, at corner, at any one, it will be same at all the corners. At any one of the corner is given by the formula, same formula, Q by z square multiplied by 3 by 2 pi multiplied by 1 upon 1 plus R by z whole square whole power 5 by 2. So my dear students, here if I multiply Q by z square is 64 tons, z is 5 square into 3 upon 2 pi, okay, into 1 upon 1 plus, what is the value of radius? Sorry, radial distance, root 5 upon z is 5 square whole power 5 by 2. So if you solve this, you will get a value of 0.77 ton per meter square. And for your information, my dear students, they can ask you, bosniks theory is best suited for, very important question amma, bosniks theory is best suited for shallow foundations. You might have heard about shallow foundation. If depth is less than or equal to width, if depth is less than or equal to width, then we assume the foundation to be shallow foundation. So here what I would like to tell you is bosniks theory is best suited for shallow foundation. So here you should be very careful in the calculating of the value R. Okay. So let us move on to the next problem. So here we have a beautiful problem. This is also one of the beautiful problems. A water tank, see students, here the agenda of stress distribution means where the stress is at some distance, you want to find out the stresses at a particular points. If you see the stress trajectory, we are not worried about the stress trajectories and all. At a particular point, how the stress is going to distribute. So at wherever you want, at a radial distance R. So if you see students, what we have observed in the previous question is, see students, at the center, the value was 1.22. Now, when you move at a radial distance of root 5, the stress was 0.77. So, what is the observation you have observed? Definitely, the stress will be more when it is applied directly at the center. And that stress is going to reduce slowly when it moves away from the center. So, these kind of practical observations you have to observe. The stress is going to maximum at the center, and as we move towards the corner, the values of stress will be going to reduce. Now, see student, the next question here is, a water tank is supported on 3 columns which form an equilateral triangle configuration. A water tank is supported on how many columns? It is supported on 3 columns which form an equilateral triangle. The total load on the water tank is how much, sir? The total load on the water tank is 200 tons. Now, the spacing of the columns is 3 meter. Assume the load on each footing as a point load. See, assume the load on each footing is what, my dear students? As a point load. Find the vertical stress induced at a depth of 2 meter under any one of the footing. Under any one of the footing. Are you clear, my dear student? Using Bosniks equation. So remember, my dear students, whenever this kind of questions are asked, you should be very careful while you are solving the problem. A water tank is supported on 3 columns. So, and it is a equilateral triangle. So here when I start the solution, my dear students, the water tank is in the form of equilateral. Okay. And here, my dear students, here we have a columns. And see, the load is going to distribute in 3 ways, equally on the 3 columns. The load is going to distribute equally on the 3 columns. So, if I consider here, total load is how much, sir? 200 tons. So, how much load is supposed to distribute here? It will distribute 200 upon 3. Okay. It will distribute 200 upon 3. And it will also distribute 200 upon 3. Now, my dear students, what is the depth? Depth is given as 2 meter. Sorry. Depth is given as 2 meter. Now, see students, he is asking what is the stress distribution on any one of the column. Suppose if I take this column as 1, this column as 2, and this column as 3. Now see students, there will be a stress on column 1 due to column 1, and there will be a stress on column 1 due to point load at 3, or there will be a stress on column 1 due to point load at 2. So please understand that there will be a stress induced in the column due to this load, and there will be a stress induced in this column due to this load also. Clear? Very good, very good. So here, whatever the total load 200 tons, it will be distributed equally on each column. So that will be equal to 200 tons by 3. That will be equal to 66.66 tons. So the load on each column. So if you observe here, the load on each column, how much it is distributed, sir? It is distributed how much here? It is distributed as 66 tons. So it will be distributed 66.66 tons. Okay, here also it is 66.66 tons. And here also it is 66.66 tons. Now, my dear students, Srujana, if you consider this column, I have taken this, any column you can take the stress. If I have taken this column 1 and this is column 2 or this is column 3, this can be 3 or anything your notation. You are trying to find the stress at this column. So, first sigma column 1 and due to the load at 1 only. So, in this case, the load is acting at the center. In this case, R will be equal to 0. When R is equal to 0, my dear students, the stress is calculated using the Q by Z square into 3 by 2 pi. So, what is Q here? What is Q? Q is nothing but 66.66 upon depth is how much, sir? 2 meter. So, 2 square into 3 by 2 pi. Can anyone tell me what is this value? Can anyone tell me what is this value, sir? This value if you calculate, it will be roughly equal to 7.96 ton per meter square. Am I correct or wrong? Very good, very good. This value is equal to how much, sir? 7.96 ton per meter square. Now see students, now due to this load, what will be the stress on column 1? So, stress on column 1 due to load 2. So, our stress on column 1 due to load 3, both will be same. Both will be same. So, if you calculate 1, that would be fine. You have to just multiply with 2. So, stress on column 1 due to load 2, this can be given as the formula. Here, what will be the radial distance? Radial distance will be equal to 3 meter, amma. Because it is an equilateral triangle. What is the distance from here to here? What is the distance from here to here, sir? The distance from here to here is 3 meter. And similarly, the distance from here to here is how much? Here to here is also 3 meter. So, here if I take radius as 3 meter, it will be taken as Q by Z square into 3 upon 2 pi into 1 upon 1 plus R by Z whole square whole power 5 by 2. So, here what is the load? 66.66 tons upon Z square is 2 square into 3 by 2 pi into 1 upon 1 plus radial distance is 3 meter upon 2 is the depth whole square whole power 5 by 2. Okay. Now, can you tell me what is this value, amma? Anyone, can you tell me? That is, this value will be equal to roughly around 0.43 ton per meter square. Now, see students, here please observe this. This value sigma 1 on column 1 due to load 2 is 0.43 ton per meter square. And similarly, the load, stress on load column 1 due to load 3 is also 0.43 ton per meter square. So if you want to find out the stress, on column 1, you can write it as sigma 11 plus sigma 12 plus sigma 13. Here you can write it as 7.95 plus 0.43 plus 0.43. If you see, this will be roughly 8.8 ton per meter square. Sir, this is a beautiful question, Amma. We can expect these kind of questions in the GATE exam. I hope you are clear. Srujana, is this clear, Amma? Can you please respond? Is this clear for you? Okay. Srujana, are you there? Can you please respond? Is this clear? Okay. I hope you are clear. Now see, students. Sir, here what we have done is we have calculated the stress on the column 1 due to load, and we have calculated the stress on column 1 due to load 2, and we have calculated the stress on column 1 due to load 3. Here the radial, in this case, as it is acting here, the radial distance will be 0, and in both the cases radial distance will be equal to 3 meter, as it is a equilateral triangle. Okay, now see, this is another beautiful question. So actually see, students, the vertical stress at some depth below the corner of a 1 meter into 1.5 meter rectangular footing due to certain load intensity is how much, sir? 100 kilonewton per meter square. Due to certain load intensity, what is the stress, sir? The stress is 100 kilonewton per meter square. Now, what will be the vertical stress in kilonewton per meter square? What will be the vertical stress in kilonewton per meter square? Below the center of a 2 into 3 meter rectangular fitting at the same depth and at same load intensity. Okay, now see, students, when you have understand this problem, they have given for a rectangle 1 meter into 1.5 meter, the stress at the corner, they are asking the stress at the corner is how much, sir? 100 kilonewton per meter square at any one of the corner. It can be here or anywhere. Now they are asking, there is a rectangle of 3 meter, this is 3 meter and this is 2 meter, and they are asking the stress at the center. They are asking what is the stress at the center. But remember, my dear students, here there is no load given, or no depth is given. But they have told you one important thing. Here what they have told you, at same depth and same load intensity. At same depth, here also the depth is same. Here also the depth is same. Here the same load intensity and here also the same load intensity. So how to solve this problem? So my dear students, if I consider this as a rectangular footing, so the beautiful concept here, please listen carefully. Here it is 2 meter, here it is 2 meter, and here it is 3 meter. Okay. Now if you divide this into 4 equal portions, if I divide this into 4 equal portions, so what will be this distance? This will be 1 meter, and what will be this distance? This distance will be 1.5 meter. So see, students, it's a basic common sense. They have given for this rectangle, what is the stress at the corner? The stress at the corner is how much it is? It is given as 100. Now this is also same portion. Here also it will be 100. Here also it will be 100. Here also it will be 100. So the stress will be equal to 100 plus 100 plus 100 plus 100. Are you able to understand? My dear students, they have given the stress of this portion at corner as 100. Now for the entire thing to find out the entire value, due to this rectangle at corner it will be 100, and due to the second rectangle it will be 100, third it will be 100, fourth it will be 100. So the total stress will be equal to 400 kilonewton per meter square. That will be equal to how much, sir? 400 kilonewton per meter square. Is this clear for everyone? Is this clear, sir? Okay, I hope you are clear with the total vertical stress. Okay. Now see students, actually we have studied the bosniks theory, right? Srujana, is that problem clear for you? Now when I talk about the bosniks theory, okay, if you talk about the vertical plane and a horizontal plane, how the stress is going to distribute. If you consider this as a horizontal plane, the stress is going to distribute in this way. The stress is going to distribute in this way. So usually the stress will be maximum at center in a horizontal plane. So how the stress is going to distribute? The stress is going to distribute parabolically, and it is having a maximum value at center. Now my dear students, this is in case of a horizontal plane. This is in case of a horizontal plane. So my dear students, if I want to understand the vertical stress, if a load Q is acting, this is an important question. In a vertical plane, if you consider in a vertical plane, okay, if I consider this as a vertical plane, so if I consider here vertical plane, the maximum value of the stress here, the maximum stress is at this point, okay, and this angle they can ask you the value at which angle the stress will be maximum in a vertical plane. The angle here is 39 degrees 15 minutes, and if you consider this as the radial distance r, and they have given r by z value also equal to 0.817. Sir, these are very, very important values you have to remember. They can ask you, you have told already that the vertical stress is maximum in a horizontal plane at the center, and the stress is going to distribute horizontally. But what I would like to tell you here is, if you talk about a vertical plane, what is the angle at which the stress is maximum is beta is equal to 39 degrees 15 minutes, and we have the value of r by z. What is r, my dear students? R is nothing but the radial distance. If you want to be more clear, r is nothing but the radial distance. Z is nothing but the soil depth. Z is nothing but the depth of the soil strata, you can write. Okay, so I hope you are clear with this. Now, my dear students, in GATE 2020, there was a question, okay, until now we have studied the vertical stress due to a point load. Now, how the vertical stress is going to vary, or what is the formula vertical stress in case of circular loading. And remember, my dear students, you have to remember these formulas, because we can expect GATE questions on this. Even though I know they are difficult, but you have to remember those. Okay, there is a derivation part also which is not required. If I consider this as the soil depth as Z, and now see, this is due to what, sir? Circular loading. The loading seems to be circular loading. Sir, what is a circular loading is, if you see the top view, sir, how the loading will be there? It will be acting on the entire circumference. This is nothing but what, sir? Circular loading. So if you consider this as theta, and if I assume the radius of as A, okay, the vertical stress due to circular loading at a depth Z is given by the formula Q into 1 minus cos cube theta. Okay. Now, my dear students, what is Q here? Q is not loading. It is intensity of loading. And it will be always in the units of stress. Because theta doesn't have any units. So it will be the units where the load is given for a particular area. So here you can write what is Q, my dear students. Q is nothing but the intensity of loading. Srujana, are you following? So here, how do you find out cos theta? So if you see, this is depth. What is cos theta? Adjacent by hypotenuse. You can write cos theta is equal to z upon root over a square plus z square. So my dear students, you can write this formula as Q into 1 minus of 1 plus a by z whole square. Only for this portion you can write here as 3 by 2. Okay, or if you are comfortable in remembering in cos cube theta and remember this diagram, it would be very helpful for you. So the vertical stress distribution at a depth z in case of a circular loading, in case of what, my dear students? In case of circular loading, sigma z is given by the formula what? Sigma z is given by the formula Q into 1 minus cos cube theta. Okay, and now immediately this, if you use the following, very good Srujana, very good. Now Srujana or anyone, my dear students, you can ask me one important thing also, sir. What is the important thing? What you can ask me is, sir, until now you have told for a circular loading. Suppose if you are talking for a ring, right? If you are talking about a ring, that means here it will have a radius r and it will have a radius capital R. Okay. So in this case, what you can do is calculate the stress of outer ring. Calculate the stress of outer ring and take a theta. Q into 1 minus cos cube theta 1. Okay, from the principle of superposition also you can write sigma of outer ring and sigma of inner ring. If you do, it will be Q into 1 minus cos cube to theta 2. So if you talk for a ring, so if I write it as stress of outer minus stress of inner ring, you can get a value of the vertical stress distribution. Q this, it will be minus. So you can write it as cos cube theta 2 minus cos cube theta 1. So please remember this, students. If you get a negative value, please make it a positive because the stress won't be negative in these cases. Okay, sometimes theta 2 is greater than theta 1. So those things mathematically you should be clear. So what I have done is the stress distribution for a circular loading I have told you, but in some of the problems they can leave for a ring or anything. So calculate the stress of the outer ring and the inner ring, and if you do the difference of these two stresses, you will get the stress. Now another important thing they can ask you, in case of a line loading, what sir? The vertical stress distribution in case of a line loading. So my dear students, when I talk about in case of line loading, so here if you see here the stress, the line loading will be something like this. Okay, or you can say line loading is nothing but, in simple words, uniformly distributed loads. And if we consider this as a soil strata, and if I consider this as a soil strata, okay, now see students, the stress at a depth z, the stress at a depth z is given by the formula 2q into pi z into 1 upon 1 plus x by z whole square. Okay, this formula seems to be difficult, but there is no other options. You have to integrate the things, that is very difficult. So in case of line loading, sir, what is x means? This is the x distance. Okay, so that is nothing but the radial distance here. So what is q here? Q is nothing but the intensity of loading. What is z? Z is nothing but the depth of the soil strata. So my dear students, please understand these formulas what I have written for bosniks theory. Sir, see, the first one, the basic formula is sigma z is equal to q by z square into 3 by 2 pi into 1 upon 1 plus r by z whole square whole power 5 by 2. So this is the value in case of depth. Now in case of circular loading, I am writing, in case stress due to circular loading, here you can write it as, what is the formula? You can remember as Q into 1 minus cos cube theta, or what is cos theta? You can also write it as Q into 1 minus of 1 plus A by Z whole square whole power 3 by 2. So this is the stress distribution formula in case of circular loading. In case of line loading, if you write here, the stress distribution in case of line loading, okay, it is given by the formula 2Q. Sir, what is Q? Intensity of loading, 2Q into 1 upon 1 plus x by z whole square whole square. So these are the values of different stresses under different loading conditions. I hope you are clear. Very good student. Now see students, I want to tell you one important thing, Amma. Sir, actually when you talk about bosniks theory, there are some limitations. What is the limitation? You are telling the type of loading. You are predefining the loading. That means a load should be a point load, a load should be a line load, a load should be a circular load, like that. But if the load is of different shapes, then how can you find out the stress distribution, my dear students? And remember, the intention of bosniks theory is, if you can identify, sir, see, actually when you are laying the foundation, when you place a foundation on the soil, the foundation will, due to the foundation, if there is a soil settlement or anything, there can be a chances of pressure bulbs. So to avoid the pressure bulbs, actually because what is a pressure bulb is, where there is a maximum pressure intensity, you will try to understand these pressure bulbs. So to identify, when you are laying a foundation, you should understand where are the pressure bulbs. To avoid the pressure bulbs, we want to study this. So let us start this. Now my dear students, I would like to, now here, let me understand you one important thing. One important thing what I would like to tell you is, we want to discuss about a chart called Numark Chart. What, sir? Numark Chart. And remember, first point I would like to tell you is, Numark Chart, this chart is based actually on bosniks theory. The basics is, it is also based on which theory? It is also based, Numark Chart is also based on bosniks theory. And now see, sir, the loading can be any shape. It need not be a circular, or it need not be a point load, or it need not be any shape. Loading can be what, sir? You can write here. Loading can be any shape. Now let us understand what actually is Numark Chart. Let us understand what actually is Numark Chart. I hope you are following, my dear students. When I talk about the Numark Chart, see students, suppose if I consider this as a Numark Chart, we have some radial lines. We connect here. These are the radial lines. All these are what, sir? These are the radial lines. And if I consider this as concentric circles, what are these? These are called what, sir? These are the concentric circles. So here what is this? These are the radial lines and these are the concentric circles. Now see students, here each sector, these are all called sectors. Now each sector causes, or each area, or you can write each sector causes equal vertical. They have assumed that each sector is going to cause equal vertical stress. Equal vertical stress. It is used to cause equal vertical stress at center. Okay. So the loading can be any shape. The loading can fall within this chart or outside the chart. It is unnecessary. It can be any shape. You can find out using Numark Chart. So how to find out this? Sir, the stress at any depth Z is given by the formula using Numark Chart as I into N into Q. So whenever you are talking about this Numark Chart, the stress at a depth Z, what is I, sir? I is known as influence coefficient. What is I, my dear students? I is known as influence coefficient. I is known as the influence coefficient. And how do you find out this I? You can write I is equal to 1 upon number of radial lines multiplied by the number of radial lines multiplied by the number of concentric circles. Number of radial lines multiplied by what, sir? Number of concentric circles. So here if I talk about radial lines or concentric circles, what actually is number of radial lines or number of concentric circles, I will tell you. See here, if you see the chart, my dear students, if you see, these are all what? Radial lines. And here we have the concentric circles. Okay. Now we assume these as radial lines, and this is a circle having same center with different radii is nothing but the concentric circle. So how you have find out I. And what is N here is, N is the number of sectors, N is the number of sectors, and Q is known as the intensity of loading. What is Q, sir? Q is nothing but the intensity of loading. And remember, my dear students, you might be finding difficult to remember all these formulas, but there is no workaround. If you have to remember these formulas. There is no workaround, because these formulas, when I am teaching offline, I've seen when our students are interacting with me, sir, it is very tough to remember the formulas in stress distribution, they will ask me. But the only way you can overcome this is you make a chart of the formulas in your room, or you make a screensaver or status, so that you can see, by looking into the formulas n number of times, you can remember that. Okay. Now see, students, you told Bosniks theory is best suited for what, sir? Shallow foundation. Now we have a concept called pressure bulb. Okay. Before talking about the pressure bulb, sir, actually pressure bulbs are nothing but this. If you see the foundation also, due to the pressure bulbs only, the bearing capacity of the soil will be reduced. Okay. Due to the pressure bulbs, due to this overlap also, if you see in group capacity of piles also, there will be a reduction in the bearing capacity, reduction in the load carrying mechanism. Very good, Amma. Very good, Surajana. Actually, due to this pressure bulbs only, there will be a load carrying mechanism will be reduced. So what is actually a pressure bulb? So before starting what is a pressure bulb, we have to understand a term called isobar. Now, my dear students, what is an isobar? Sir, what is an isobar? Isobar means, iso means what, sir? Same. Bar means pressure. A line joining points of, iso means same, bar means pressure. A line joining points of equal vertical stress, because we are talking about the vertical stress or pressure. A line joining points of equal vertical stress is nothing but what? It is nothing but the isobar. A line joining points of equal vertical stress is nothing but what, sir? Isobar. Very good. It is a stress contour. Very good. Very good. Kartika, well, very good. Very good. Okay, next. Kartika, well, very good, sir. Now, when I talk about this, we have a concept called pressure bulb. Sir, what is a pressure bulb? Sir, a contour means it is an imaginary line joining points. Okay. So here what is a pressure bulb is the zone of soil mass. If you consider a zone of soil mass bounded by given vertical pressure intensity. Bounded by given vertical pressure intensity. The zone of soil mass bounded by given by vertical pressure intensity is known as pressure bulb. And I told you clearly how the pressure bulb will be there, Amma. This is also nothing but the pressure bulbs. Means in this zone, pressure bulb is Bosnik theory. Sir, please see here pressure bulb. What I would like to tell you is pressure bulbs we have to avoid these pressure bulbs. What I didn't get you, Karthik, but what I would like to tell you is the load carrying capacity of the pile or foundation will be reduced due to these pressure bulbs, and we have to avoid these pressure bulbs. So how can you avoid these pressure bulbs? Means you have to have an idea on the stress distribution. So to have an idea on the stress distribution, you are studying about the bosniks theory. Now see students, we have another theory called Westergaard's theory. We have another theory called what, sir? Westergaard's theory. Okay, and I told you Bosnick's theory is best suited for what? I told you Bosnick's theory is best suited for shallow foundations. But if you talk about Westergaard's theory, this is best suited for stratified soil. What is stratified soil means? This is best suited for stratified soil. So what do you mean by stratified soil here? Anyone, my dear students? What do you mean by stratified soil here? What do you mean by stratified soil, sir? A soil. Very good, Dilip, very good. So here what do you mean by stratified soil? A stratified soil is nothing but a soil in the form of layers. A soil which is in the form of layers is nothing but the stratified soil. Okay. Now, when I talk about the Westergaard's theory, it is best suited for stratified soils, and here the stress is given by the formula in Westergaard's theory. It is Q by Z square into 1 upon pi into 1 plus 2 into R by Z whole square whole power 3 by 2. This is important, my dear students. Here it is 3 by 2. When you talk about the Bosnick's theory, it is 5 by 2. So the stress at a depth is given by the formula Q by Z square into 1 upon pi into 1 upon 1 plus 2 into R by Z whole square whole power 3 by 2. I hope you are clear. And remember, Westergaard's theory is best suited for what, sir? This is best suited for which foundation? This is best suited for shallow foundation. This is best suited for shallow foundations. Sorry, this is best suited for stratified soil or soil which is in the form of layers. Bosnick's theory is best suited for shallow foundations, and Westergaard's theory is suited for stratified soils. Now see students, we also should have an idea on the contact pressure. We also should have an idea on the contact pressure. Now, when I talk about the contact pressure, see students, it is the pressure exerted between the soil and foundation. And see students, almost in every alternate year, in any of the competitive exams, we are seeing the diagrams. Directly they are giving the diagrams. Sir, what is contact pressure? It is the pressure that is acting between the soil and the foundation. Suppose, see students, if I talk about a rigid footing, now this is the rigid footing and this is also rigid footing. Okay. And if we talk about the clay, and here we have the sand. Okay. Here if you talk about the settlement, please observe this students. In case of rigid footing and in case of clay, when you talk about settlement, this is called what, sir? This is the settlement. We call this as settlement. And here in case of rigid footing, the settlement will be uniform. Please understand, very, very important question. You can put star mark also. The settlement is uniform in case of rigid footing, in case of clay, as well as in case of sand. But here if you see the contact pressure, the contact pressure is how it will vary. It will be maximum at the corners. In case of clay, the contact pressure will be maximum at the corners and it will be minimum at the center. But in case of sand, The contact pressure will be maximum at the center and minimum at the corners. Are you getting, my dear students? This is a very good, sir. Very good. Here in case of rigid, in rigid footing, the settlement is uniform in both the cases of clay and sand. But if you see the contact pressure, this is the contact pressure. The contact pressure. Okay. Here the contact pressure varies. See, here the contact pressure is maximum at the corners and minimum at the, here it is maximum at center. This is for what, sir? This is for sands and this is for clays. Now see, students, if you want to understand in case of a flexible footing, sir, see, if you want to understand the same thing in case of flexible footing, if I talk about the flexible footing, okay, in case of flexible footing, the contact pressure will be uniform. What, sir? Here, in case of flexible footing, when I talk here, the contact pressure is uniform. So you have to understand here, the contact pressure is uniform in case of both clay and sand. The contact pressure is uniform in case of what, sir? In case of flexible footing. But if you see the settlement will be varying parabolically. This is the settlement graph. Okay, it will be parabolically here. And in case of sand, the settlement will be something like this. These are the, so here what you have to observe, where is the settlement maximum, where is the settlement minimum. So these diagrams are very important in case of, very good Karthik. So these are the diagrams, Amma. You just remember these diagrams. Sir, actually what happens is, this is a clay. Usually when you apply a load at the center of the clay will easily compress. But at the corners, the soil will be bulging out. So that is the reason in clays, the contact pressure will be maximum in case of rigid footing. Okay. Now see, students. So here what I would like to tell you here is very important thing, Amma. The important thing here is at IMS GATE Academy, we have a genuine single digit rankers. Okay. And they have been taking offline gate coaching at IMS Jayanagar, Bangalore, and also at Ben Circle, Vijayawada. So what we have done, see, if you want to have, these are our toppers list, sir. You can visit our playlist also. We have done the interview with the individual students. There are some of the students are from Jayanagar, Bangalore, or there some of the students from Vijayawada, Ben Circle. So what we are providing at IMS GATE Academy is, we are providing a free gate coach, means free classes. If you can visit our website, IMS India GATE Academy. So in that you will find 100+, you have to register there, and with free of cost you will get 100+ live classes, and you will get 12 chapter tests, 6 subject tests, and 6 past papers. Not live classes, sir, recorded conceptual videos. Okay, now what I would like to tell you is, at IMS GATE Academy, we offer 800+ hours of live coaching and then 130+ online tests. Here when I talk about the online tests, sir, it includes chapter test, subject test, advanced level test, multiple subject test and all. And we have theory book for each chapter, each subject, and also exercise book also we have. And we have one-to-one personal mentorship. Actually, my dear students, when you interact with the students, there might be some diploma students who might be strong in the core knowledge, but they might be weak in the mathematics. So we have wonderful professors for mathematics also. And if you talk about the mentorship sessions, my dear students, in IMS GATE Academy, we have the track record of people who are getting more qualified. If you see, out of 100, hardly 18% of the students are qualified in the overall gate. But the students who have enrolled with IMS GATE Academy, we are seeing that out of 100 students, 70% of the students are qualified for the GATE exam. That is the beauty of the IMS GATE Academy, because we achieved this, because we are continuously in touch with the students with the My Plan sessions, and also we are providing a doubt portal where the doubt can be solved within 24 hours of time. And if you want to visit our centers at Vijayawada, this is our number, Amma, 7702918777. And we have different centers. Bangalore, you can visit Jayanagar. And please see here, these are our contact numbers at Vijayawada. You can directly contact them for the online or offline gate coaching. If you are from Bangalore, you can visit our IMS GATE Academy, Jayanagar. Okay, I hope this session is helpful for you, and I would be very happy if I see more and more students. That is the only enthusiasm I could say. And I really appreciate Srujana for attending the classes regularly, and I have seen Dilip and Karthik also responding. That's a very good sign, and we'll see you with much more classes in the coming day. Okay, thank you and all the best.